So again, this model is available for download as the beginning GIS food environment V1. It's the model that we've been building up, and we're now going to go on to a situation. We thus far have built an environment, a GIS environment centered in the city of Saskatoon, where we have supermarkets and convenience stores, each associated with an agent, a corresponding agent type here, supermarket and convenience stores, and we place them according to their empirical locations. So we had searched within GIS, found search results for them, and instantiated agents at those locations. In addition to that, we're going to scatter around a set of homes here. There's a way that I prefer to do that, but as I'll get to, there was an issue I encountered with that, so I'm using sort of a poor man's way of approaching it. And in order to approach that, I would simply note that if we go to the, in main, if we go to the map, one of the things that we'll find is that that we have a latitude reported and longitude reported for the region of interest. Okay, so latitude is 52.14 or 15 essentially, and minus 102.62 in terms of longitude. We're going to come back to those numbers in just a minute. First, I'd like to go to, we can move over in main so that we can see areas. And I'd like to drag in to here to create a population of homes. So how am I going to create a population of homes in AnyLogic? Anyone? Drag in a home. So I'm going to do that up here. We're going to drag in a home. We're going to call it homes. Now, does that action in and of itself make it so? What do we have to do to turn to a population? We're going to click population of agents. That's right. Okay. Okay, and we'll leave it as a default, given the strictures of time. We'll leave it as 100 homes by default. Okay, and we will go for the home. You'll notice there's an initial location there that's reported, and we're going to say at the specified latitude, longitude. Okay, do you see that for initial location? You may have to expand the initial location area. Do you see it says add latitude, longitude? Now this is where I have a different preference for how to handle it. The API, the so-called application programming interface for AnyLogic, should in theory allow for placement at a random place within a given region. However, it was reporting to me that that was currently unsupported, so I need a student to investigate that and report to me under what situations it is unsupported, if it depends on the provider of the map or what have you. But in short, I can't undertake that as originally hoped. So we're going to place homes in a uniformly distributed set of locations, uniformly drawn from a random variable that's uniformly distributed. So for the latitude, we're going to set them around the location of the map, and it's going to be uniform between for latitude between 42.09 and 42.19. And I'm a bit winging this, so we're going to have to look at the results and tune this. This is just based on the location of Saskatoon. And longitude, excuse me, between minus 106.57 and minus 106.67. Now, I have reason to think that there's going to be a little bit of an issue with those, but we'll give that a try. that is simply centered at the location of the map that I had indicated before. Okay, so here you'll notice that that we had reported these locations. Excuse me, I screwed up. Okay, so this should have been 52, of course. We're not at 42. 42 is down somewhere somewhere down near I don't know, Nebraska or something. So ladies and gentlemen, we're going to need to go back to homes and say 52. Sorry about that. 52.09, 52.19. Okay. I don't know what I was thinking there. Okay, great. Okay, so ladies and gentlemen, let's run the model and let's see what that brings. Okay. Okay. Here we go. Okay, so we're going to run this, and we should see a set of homes scattered around what looks to be the kind of middle section of the city. So we're going to expand that a little bit, so it's a little bit larger, more expansive, particularly in terms of longitude. We're going to sort of double the width, and we'll go larger as well in terms of latitude. Again, there is a mechanism within AnyLogic, ostensibly, for placing it in a random location within the city boundaries. But again, I need a TA to investigate that. Tina, is that something you could try to look at? Okay, it's called random point within region or something like that. You could call map dot. It's called something like get random point inside. I think that's what it's called, or random point inside. Okay, it returns a point. Anyway, the king could help. Winchell. Okay. Okay. So we're going to go back to homes, and we're going to expand this a little bit. So for latitude, we're going to go. We're going to bump it up a bit to go from on the lower side. 52.04 all the way up to 52.24. Okay, and similarly for longitude, we'll go from minus 106.52 to minus 106.72. Okay. So again, latitude from 52.04 to 52.24, for longitude from minus 106.52 to minus 106.72. Yes. Okay. Okay. And I'm going to say run this, and if you run it, you should see, okay, now they're scattered around. Maybe we need to expand it a little bit with the longitude yet further. So sorry, folks, we'll do one more round here with homes. We'll do it from longitude point minus 106.4. Okay, oh wait, that's okay. So right. So we will expand it outward. This is the upper one. So this is going to go to 5, I'll say to 0.6 minus, so that's going to get, sorry, I've got to be careful here. So we need to get this lowered, right. So it's from minus 106.45 to, so it's getting closer to 0, and this one's getting further from 0. So minus 106.80. Okay. Sorry for the futzing. We'll leave it at that in any case. Minus 106.45 to minus 106.80. For longitude alone. And we'll run this, and we will run it, and okay, now we have a broader distribution. good. Okay, great. Okay, so does anyone need that spelled out again? Want a little bit more time for it? No? Okay. And then we'll proceed here. Okay, so the next step, ladies and gentlemen, is going to be we're going to give representations for people, okay? Great. So here we go. And we're going to go to a person. Double click on person. Oh, sorry, there's no person. Sorry. Create a person class. Person, agent type, capital P. Okay. Yeah. Yeah, an endpoint side, exactly. I call that on the map, and it says, it freaks out and says that unsupported service. So I need to find out if we change map providers, does it now work? Right now it dies horribly on mine. Okay. Okay, so we're going to go to home, and we're going to go to the palette, and we're going to go to this geometric area of the palette, this presentation. And we're going to drag in oval. Okay. And we're going to draw two ovals, okay? One of them, so actually, don't fuzz with it. Like me. Drag in an oval and go down to the position and size, and we're going to set this to be radius. It's going to be an oval, selected as an oval. Radius X is going to be 3. Radius Y is going to be 5. Okay? And the X location is going to be 0, and the Y location is going to be 0 as well. Okay? So it's going to be placed up there. And we are going to call this body oval. Okay, body oval. Okay? Next, we're going to drag in a head. And we are going to set it's going to be a circle, and it's going to be of radius 2. Boom. Oh, radius 2. Boom. Oh my gosh. Okay, it keeps on bouncing back. Okay, there it is. And the X location of that is going to place it just above the body oval. Okay, so it's going to be Y location 0, and it's going to be X location minus 1, let's say. Okay, let's make it minus 2. He looks right now uncomfortable, so it's going to be minus 2. Okay, Y location. Okay, and I think, oh, he still looks, uncomfortable. Okay, let's make it minus 3. Okay, there it is. Okay, that's a little bit better. Oh man, I thought, okay, minus 4. I don't want him to look headless. Well, okay, minus 5. Is that better?
Yeah.
Okay, that's great. Minus 5. Sorry. I don't know. Oh, of course, it's a radius, not a. Yeah, minus 5. Of course, it's a radius of the in the y direction for the other one, not a diameter. Okay, sorry, folks. Okay, so that's minus 5. I need to annotate that. Okay, great. So this would be body oval at 0, 0, 0, 0. And head at 0, minus 5. Okay, great. Thank you. Okay, so we're gonna, now we have these people. Now we're going to go create a population of people. How do we do that? Where do we go? The population is going to live in Maine. So where do we go? Go to Maine, and then do what? Drag in person to create the population. Okay, great. And this will be called population. Okay? Now, what do we have to do to truly make it a population? Exactly. Okay, and we want to get a parameter that will set the population size. It will be called population size. So we're going to drag in a parameter from the agent palette. It's going to be called population size. And what sort of parameter is it going to be? Integer. And its default value will be 10. Okay, and have just 10 people for starters as a default. One of the reasons I'm doing this is to just make the simulations very quick, because if we have a larger population, AnyLogic is going to have to go hit the routing server a lot, saying, how do I get from here to here? And it's going to take longer to get going. Once it gets going, once it's so-called cached, those saved away, those routes, it's faster. But I prefer to have low population as a default. So the population size is 10. It's an integer. Okay. The population then, where do we put the population size to make that actually the population size of that population? Where do we have to modify it? Initial number of agents, make it population, main dot, or this dot population size. Okay, great. Great. Okay, ladies and gentlemen. Good. Okay, we're going to, you notice here that there's some things you can set for interest of time to get us to luncheon time. I'm not going to go through some of these, but you notice there's a movement initial speed in meters per second for the person. And in fact, if you went and looked at the person as in the person class here, you could excuse me. I take that back. It's not actually in the person class. It'll be in the person population. No, it's actually in the, okay. Scrub that. Certain of them are going to allow you to specify routing rules for them. And for right now, for technical reasons, that doesn't include the person population. Oh, excuse me, it does. Here it is. Yeah, person population, we could specify routing features. Okay, so ladies and gentlemen, so here we're going to have this population of people. Now, where are those population going to live of people? Well, in this case, they're going to live at homes, okay? So we're going to go, and for that population, we are going to set the agent so that in this population, we're going to associate it with a home. And that home will set their latitude, longitude. Okay? So they're going to be associated with the home. Now, in order to do this, ladies and gentlemen, we first have to go to person, and we're going to add a parameter to person that will be their home. Note that. A parameter in person doesn't have to be a double precision value like age or income, or an integer like, you know, number of past children. This could be something that's another type of agent. It's a reference to an instance of that agent. So if we go to person and we add a home parameter from the palette, we're going to pick a type here. And what sort of type do you think it will have? Home. Be a reference to an instance of home. Okay? We're going to leave the default value blank here, but we're going to go back. Yes?
Just a question. Would that be better to name it as home location since we have a home agent?
No, because this is going to be, so this is going to represent their home. It's a reference to their home. It turns out we will use some location information from it, but it could be that we want to use some other information from the home. About its characteristics or whatever. So really we want to associate them here with a home, and that's why this is home, okay? We'll see, we'll set their location from that home later, but that'll be a somewhat separate issue. Okay, so ladies and gentlemen, now we have a population of people who need a home, right? Because we added that parameter to person, home, Now when we go to the population, just like in that on Tuesday, when we associate people with an income parameter, we needed to, for the population, specify what assumptions to have about that income parameter. Do you remember that? To draw it from a log normal distribution, or we associated characteristics with their sex. We could draw it from a custom distribution, or what have you. So here we have to set their home. So, ladies and gentlemen, for the home, I'd like to set it to be home, this dot homes. So this is in main, under the population. The home parameter will be drawn in the following way. We'll say this dot homes dot random. We'll pick a random one from amongst the homes to associate with this particular agent. So remember, each agent's going to be created in turn, and for each agent to determine their home, it's going to run this code. It'll set them at a random location. Do you see that? Yeah, Chris.
They don't have to be unique, though, do they?
Right now, they're not unique, so it's possible two people could be placed into the same home. If we wanted to be unique, what we would use is this little thing here called index, which would allow us. Let me show you. I'm not saying you should do this. I prefer you put them in random, but let me show you how you'd use that. Let's suppose they wanted to put them round robin into homes. So the first one will go in the first home, second one will go to second home, so on. Maybe there's 400 people, 100 homes, and they'd be placed uniformly. If you wanted to do something like that, you would do homes.get here, and we would get the value of this index. So we would need to say, okay, index, suppose there's more people than homes, it'll be the index of the person, maybe it's person 200, and we would take its modulo the number of homes, this dot homes dot size, and that would give us the size. And so this taking it modulo means, let's suppose there's 10 homes and there's 20 people. First person 0 will be placed in home 0, person 1 in home 1, person 2 in home 2, all the way up to person 9 in home 9. Person 10 would be placed in home 0, person 11 in home 1, person 2 in home 3. So modulo is like taking when you divide it by what's the remainder that's left, okay? That's what that modulo would be. So if we want to distribute them evenly amongst the homes, we could do that. But I prefer for this case to just assign them randomly to homes, okay? Okay. The point is we're assigning a home to them. Now, by virtue of assigning a home, as Peter asked, there's a latitude, longitude implied. And what is that latitude and longitude? Well, it's going to be the home's latitude, the home's longitude with which they're associated, right? Do you get my point? If they're given a home, this particular house, to associate a latitude and longitude with the person for their initial location, we're going to place them in the home. So we're going to have their latitude be the home's latitude. Longitude be the home's latitude. Now, you might think you could just say home, they have a home, dot get latitude. But it's going to be very unhappy if we try to do this. Why is it going to be unhappy? Why is it going to be unhappy? Because it doesn't know where to find home, the home. So how do we refer to, we've done this before, we did it on Tuesday quite a lot. If we want to set a characteristic for that person, maybe it's a parameter, maybe it's their location, and we want it to depend on one of their other characteristics, like their the value of a parameter, like home. How do we do that? How do we say, as they're being created, we're setting their latitude, how do we say my home? Self. That's exactly what we do. We do self. Self. So remember on that on Tuesday we had their income depend on their sex. So depending on self.sex, we use different income distribution. So we're going to use self here. Now, a concern that I want to highlight here is the following. What I'm not showing you here is the some of the dependencies here. So one issue is, in order for this to work, we needed to create the population of homes before we created the population of people. so that there was a home already, the homes were already established by the time we were assigning people homes. Because we're asking the homes collection, give me a random home. If we had actually added that after we added the person population, it wouldn't have been a happy camper. There would have been no homes at all to allocate. It was because we created the homes prior to population. The second thing is, ladies and gentlemen, when you have parameters for people and there's interdependencies, you either need to be careful to add them in the right order so that the ones that depend, so that later ones depend on earlier ones, or you have to rearrange the parameters through the interface and AnyLogic so they're in the right order. In this case, the latitude and longitude are set after the parameters are set for the agent, so it should be fine.
Dr. That's good.
Yes.
Another way to avoid it is to use the internal database to do it.
Yeah, but we haven't presented that yet. That'll be presented in another
Okay.
session. Yeah.
No problem.
Okay, so ladies and gentlemen, and I prefer to, given the database cruft, I prefer to, if there's an easy way to do it without using the database,
Okay.
to do that. Okay, so ladies and gentlemen, assigns to homes. You'll notice each person is assigned to a particular home here. So all persons are assigned to homes. Now, there's fewer people than homes right now, so there's a lot of empty homes. Okay, TAs. There's many TAs who are needed right now. Okay. Kate okay, back there. Okay. Kate needs help. So what did I do, ladies and gentlemen? I went through a multi-step process here. I went to person, I added a home. This home is of type home.
Oh, I didn't, wait, I know what it is.
Right? Okay. I then went to main. I added a population of homes by dragging home in here. I made it a population of, excuse me, we did this earlier, homes, but I added a population of people, and for the population of people, for people's homes, I drew it from the set of possible homes, and for the latitude and longitude, I simply drew it from the home with which they're associated, okay? So each person is associated with a home, as drawn randomly from the homes, and we set their latitude and longitude depending on the homes. Okay? Okay. Okay, so, ladies and gentlemen, we have here a situation now where people are located at homes. So, this will allow us to start to think about the dynamic portions of this model. Now, okay, this is getting low. I'm going to have to replace the batteries for this. Okay. Okay. Here we go. Okay. So, ladies and gentlemen, this is a full day example that I play out in my boot camps when they're not combined with incubators. We don't have time to do that here because we're going to be devoting this afternoon to project work. So we're going to be having an abbreviated portion of this, and you can find online several courses where I've delivered this separately. What we're going to do now is going to emphasize the type of understanding that that I want to build up as far as how to make agents circulate in a spatial environment. Okay, that's really what I'm trying to communicate here. We could additionally build up some other features that will be of interest. In the fulsome version of this model, it's a hybrid model. We have stocks and flows. We have action charts introduced for decision making about food seeking. We have preferences, but I want to get at least the basics conveyed before we go to lunch. So I'm going to go to person, and what we're going to add in is a familiar construct, but it will have some unfamiliar parts. What we're going to add in is a state chart, okay? And the state chart is going to be simplified compared to, in terms of its features compared to what we normally see, okay? So, ladies and in terms of the actual full logic that would be in the full model. Okay, so I'd like to go to person, and I'd like to go to the state chart palette, and I'd like to start adding things in here, okay? Food procurement state chart is going to be its name, state chart. Okay. Great. Ladies and gentlemen, next I am going to say not seeking food. So there's going to be several states here. Not seeking food. There's going to be a state of heading to supermarket. There's going to be a state of shopping. Notice how I'm arranging these things. It's not linear. Shopping in supermarket. And there's going to be a state of in transit transit to home. Okay? Next, there's going to be a parallel set of these that's going to be shopping in convenience store and heading to convenience store. So it's kind of a parallel set of transitions here, roughly symmetric. Heading to convenience store. Okay. That's going to be our little state. Those are going to be states in our state chart. So we've characterized the possible state someone could be in with respect to food procurement. We now want to knit them together, okay? And we're going to, again, do a simplified version of this, okay? So first, I'm going to drag in a transition here that's going to be called going shopping, okay? And it'll be a timeout transition every, a rate transition of, on a per day basis, every 0.2 days, okay? Or might be easier to describe it as 1.0 divided by 5.0, meaning every 5 days on average they're going to go shopping, okay? That's a rate transition. Now, there's going to need to be something which vectors them to either supermarket or heading to convenience store. And what will be that sort of thing? Well, we want a branch, ladies and gentlemen. And one side of the branch will go to supermarket, and one side of that branch will go to convenience store. Okay? You notice when you have this, these branches, these transitions don't have a logic. It's not like they fire at, as a timeout or as a rate, because basically when this fires, you will go down one of these immediately in 0 time. So when this fires, this is worth noting. When you have these states leaving a branch, as soon as you come into the branch, you'll leave via one of those. It's really this that has to be triggered. Okay? Heading to convenience store, heading to supermarket. Okay? They're going to go one of those directions. And ladies and gentlemen, for now, we're going to set for this branch here, this branch construct, we're going to say choose destination. And we'll show the name. Okay? And in fact, we'll show the name for this one above there. Show name. It's good practice to show name. Now, by the way, I should emphasize, in terms of layout, you folks don't have to do this, but I would just want to illustrate a point. You notice it's quite helpful visually to be able to look at this and know that this is a rate transition versus a timeout versus a message an arrival transition or a message transition. We'll soon learn about arrivals. If I had pulled it up here, sometimes you can't see that clearly. And in fact, in earlier versions of AnyLogic, and I thought still, if you make transition small, I may be wrong, maybe they've fixed this, you're not going to be able to see the icon properly. So giving some extra space is kind of nice to see the icon clearly. Okay? Next, ladies and gentlemen, we're going to connect the transitions here up to each of these. Now, these transitions will be a new type. Ladies and gentlemen, under what situation at a practical level, if you're heading to the supermarket, when are you in fact going to start shopping? Okay, so you're driving to the supermarket along the 405, and you, under what conditions are you going to actually be able to start shopping? When you what? Arrive at the supermarket. So this transition type is going to be what's called an agent arrival. Okay? Agent arrival. And same as this one here. It's going to be an agent arrival transition. It's going to be triggered when we get there. Okay? And we can say, we can give them a name. Start shopping in supermarket, or start shopping in convenience store. In convenience store. Okay. Now I'll show the names. They're not the most insightful names, but I'll show them in case anyone wants to sort of copy them. Okay. Here we go.
So what does that mean again, agent arrival?
It means when they arrive at the destination. If they're moving, when they get there, they'll start shopping. They're actually going to be moving. Yes. They're going to be moving in a continuous fashion, and when they get there, they'll start shopping. So it's not going to be the case we just move them to a place and have them start shopping. They're actually going to be traveling over time, and when they reach there is going to be. Thank you. That's great. Fantastic. When they arrive there, they're actually going to then start shopping. It'll determine when they arrive there based on their speed and based on the type of route that they take. So their arrival time is endogenized. It's computed by the model. We don't specify. Yeah, wait.
Could you show the condition for the...
Oh yeah, I actually haven't. I've been neglectful. The condition here is actually random true of, oh gosh, oh I'm tempted, oh it's 11:35. Okay, this is what we're going to do. We are going to add to person a parameter that's going to call preference for convenience store meals. And by default, it's going to be 0.5, but we're going to have some people who have a predilection. One might even say a hankering for floaters, or screaming yellow zonkers, or pizza pops, or Dylan tells me corn dogs, of which I think Australia is yet innocent.
We call them battered sads.
Battered?
Battered sads.
Sads?
Sad, S-A-D.
Sabs.
Sad.
Oh,
Battered sabs.
Sabs.
Sab.
Sab.
Sav.
Yeah.
Sav. Battered sav. Well, I'll be. Okay. Wow, we're yet innocent of that. Okay. Battered salves. Okay. So, ladies and gentlemen, there's going to be a preference for convenience store meals that's given by that. Now this thing weight is going to be random true of this dot preference for convenience store meals.
And can I just ask one more question? This movement agent arrival from, is that because of the map that we can use this?
No, you can use it without maps as well. You can use it without GIS, and it's basically when you have movement in continuous space. And one place you can do that is with GIS, but you can actually have movement in continuous space without GIS. And you'll find videos of me, for example, there's a video, institutional mobility. People move between home and work, and they actually travel, and they get to work, and then they join the work network, and stuff like that, okay? Preference for convenience store meals.
Oh, it is this.
This dot preference for convenience store meals. So we're flipping a coin with this probability, we're going to be true, in which case we'll head to a convenience store. We've got that hankering, and we're going to the convenience store to get the battered salve. Okay? Okay.
Could you show the branch come in one more time, the choose destination branch?
The choose destination.
Yeah, sure.
Yeah, all it is named.
Oh,
It does
okay.
nothing there.
All right, just making sure.
Yeah, this one, this is where the logic is, and this is the default. So if you don't go down one of the conditions, you go out the default. So the supermarket is the default. Are we okay with that?
Yeah.
Okay, ladies and gentlemen, we're a lot of the way done here with the connectivity, and then we'll just put in a bit of logic and we'll let it go for a whirl. Okay, so here we have we're going to have a transition from shopping and supermarket to in transit to home, and that's going to be a timeout transition of not 1 day, but it's going to be 1 hour. Okay, and here there's going to be a transition from shopping and convenience store to in transit to home with a timeout of 15 minutes. So you go in, you get your battered salve and pay for it, and you're out of there. Southern California has a chain of restaurants called In-N-Out. It's kind of like that. You're out with your battered salve instead of your double or whatever they sell at that. Okay. Great. So 15 minutes for this one, 1 hour for this one, these timeouts. Okay? Okay. Next, we're going to have a transition back from in transit to home, back to their home in this not food. How do we bend a transition around? Anyone remember? Yeah, we double click on it, and then we can double click on it several places and bend it. Okay? What sort of transition do you think that will be? At what point will they be back at home? Is it a timeout? Is it a rate? Agent arrival. Ladies and gentlemen, this is important. Yes, we could say 45 minutes back, but maybe they're on the 405 and rush hour traffic, and they're not going to get back for an hour and a half. Or maybe they're just hopped in their bike and they're 5 minutes away from the supermarket and they get back in 5 minutes. In short, by making an agent arrival, it's endogenized. How long it takes is endogenized. It depends on what route transportation they're using, what path, perhaps congestion or what have you. So by making an agent arrival, it will inform the agent, hey, you've gotten there. And it could take longer times at certain routes or shorter at others. It's not something we hard code. Rather, it's endogenized by virtue of the movement as captured within continuous space. And that, again, is not contingent upon GIS, nor is it it's rather a feature of continuous movement in AnyLogic. And you'll find many videos of me introducing it without GIS. Okay, ladies and gentlemen. So this Saskatoon thing, what is that?
Region name, so it's an object of the region you have selected as the...
Within the map?
Right.
So you have to say get region within the map, or?
No, the region is an object inside the, so you have access to that.
Oh, really?
Yeah.
Oh, okay, cool. Cool. Okay, so ladies and gentlemen, we have this. Now, what we have not put in at this point, though, so we've got all the connectivity. We've basically got the rules, the actions, and the states. Remember, when you start thinking about a model, it's helpful to start parsing it out into pieces. and we introduced that framework on Monday for thinking about parties, right? Properties or parameters, you could choose. The actions, the rules, the time and environment, and the interventions and the states. And state charts capture states, rules, and actions. And we've captured those here in as much as the actions are changing of states and the rules are governing when they occur. But we have yet to put in the logic within each of these states. And so what we're going to be doing is associating logic here with each of these. So for ladies and gentlemen, for going to the heading to supermarket, okay, we're going to be heading, we're going to need to move to a supermarket that's close to us, okay? So heading to supermarket, when we come into the state, we're going to be moving to a supermarket of our choosing, okay? And what we're going to use here is something that's going to set us in motion. And importantly, Betsy, this just sets us in motion. It doesn't actually put us at the destination. It just sets us in motion, and we're going to be traveling. And then when we arrive, we're going to go out via this transition, okay? So there's a couple mechanisms you can use for this in AnyLogic. You notice you could say, for example, move to straight within a certain time, or move to in a specified time. We're going to use move to here, okay? We're going to use move to, and that will set us in motion to the appropriate destination. Now, right now, we're going to do it in a particularly simple fashion, and we're going to say we're going to pick from a random grocery store element. We'll come back to this later, but we're going to say main dot grocery. Oops, excuse me. It's not grocery. It's supermarket. Supermarket collection. Okay. Dot random from. It's going to pick with equal probability among the items of the supermarket collection. We'll vary that assumption later. Okay. So let's build it, make sure it's a happy camper, and it's actually not. So it's an unhappy camper. Random from, oh, okay, great, that's interesting. That used to work. So fine. So let's see what we can do. Okay, so let's first of all see what is supported here. Is there a direct thing that supports randomly selecting it? No, there's not. Okay, that's fine. We always have recourse to a brutal way. Okay, let's see if we can do random here. Random. So you folks can wait while I select this. Okay, random from. Let's do this. Random from this collection, okay? There we go, and that should do the trick. That's fine. Yeah, random from that collection. Okay, great. So it's choosing a random one there, and we're going to do something correspondingly over here for the convenience stores. Except instead of picking, it's going to be mutatis mutandis. So instead of picking it from supermarket collections, what are we going to pick it from? Convenience store locations. Okay. Okay. And now, the only other place where we need to direct them in terms of movement is where? Where else do they need to be set? Remember, when they arrive at the destination, they'll automatically come down there. So where else do we need to sort of set them going towards a certain destination? In transit to home. So when we enter in transit to home, we'll do this dot, tell me what to type, move to, and where will I move? Whither will I move? Well, I'd like to say transit to home, right? And in fact, that works just fine.
Exactly.
Yeah. Yeah, it's a parameter. It's a parameter, and that parameter refers to a home, which has a known location associated with it. Okay? Move to home. Okay? And when they get home, they will transition back to the state. Are we okay with that? Okay.
So you didn't have to say this dot home, or you?
Oh, well, yeah, I should say this dot home. Thank you. Thank you. Thank you. To be consistent, I should say this dot home. Okay. Good. Ladies and gentlemen, does it build? Okay, if it builds, run it. Okay? Okay. If it doesn't build, raise your hand. Okay? Great. Okay, ladies and gentlemen, so here we're going to see these agents, okay? Now, these agents are going to be moving, and you'll notice down here in the lower left, do you see this little thing? It looks like downwards facing arrows. Do you see that? Oh, you missed it there. But when I first started running it, here it is doing it again. Do you see that? What it's actually doing is looking up, it's actually going over to the server and saying, find me a route between this place in Saskatoon and this other one via road. It's actually finding a road route between the two and then using that to route them, okay? And it turns out that that is going to take a little bit of time. Once it finds that route, it's going to store it away. So it doesn't have to ask the server again, you know, how to get from this location to that location. But right now it's actually going quite slow because a lot of people in this room are asking the server right now, find me these locations from one location, from one randomly chosen location to another. Okay, so it's actually going to go slow, and then it will start to speed up in terms of its movement. Okay.
When they get there, they rotate.
Yes, they rotate. Yes.
Would you mind uploading your model when you get a chance? Because
Sure.
I got behind you and there was an error. And
Sure. Happy to do that. I'll do it right now.
Thank you.
Okay. This will be called version 2. Okay. Of it, and you'll be able to run that. Okay. How many people have their models running right now? Okay. Pretty good. Pretty good. Kate's, is yours running?
Yeah, it's running, but actually they're rotating like.
Yeah, they're rotating. We'll get to the. Yeah, they're rotating because they rotate to go in so that their positioning is perpendicular, I think, to the path they're taking to the destination. And there's a way to fob the settings so that that's not the case. And I think it's in the person class properties. You could set it to do not rotate. But we'll get to that in just a second. Let me upload this in case people would like to download mine. So thank you, Josh, for asking. That's super good. Okay, here we are. And ladies and gentlemen, it's up on the server. If anyone wants to grab it, you can download it from the bootcamp site. Okay, so let's go do that. Kate, those individuals are rotated in a disconcerting fashion. You know, they might be at the convenience store and they're flat on their back, and it's not from eating screaming yellow zonkers. Okay, ladies and gentlemen. So we're going to click on person, and we are going to go look at movement. And you'll notice there's a checkbox here, rotate animation towards movement. Do you see that? So you notice you can also set how quickly they move here too, right? What's their speed of movement? I'm going to slow it down to 1 meter per second, just so we can see them as if they're walking to their destination. Okay. Now, again, you can set on the map whether you want it to use walking routes or bike routes or streets. and that would be for a set of options. Scott, question for you. Do you know in GIS, is it possible to have some agents who use cars and some use bikes and
Yes,
some
actually,
walking?
Reed just asked me that question. The way you do that is that there's a route provider object
Yes.
in the markup.
Yeah.
And that allows you to specify its own route system, so
Yep.
you can specify that. And then you can tell any agent when they move to use a specific route provider.
Okay, so that was that check, that drop down I showed earlier where it said routing. Each agent has in its properties, we saw that earlier, although there were no choices for it there, but is it this, excuse me, it's in the population of the agents. There's a route, and it's further down here, as I recall. Yes, it's routing, right?
Yes.
Yeah.
So you can change that to, if you have a different agent, if you pull a route provider agent or object onto the
Oh, it requires a route provider object explicitly.
Yeah, and you just drag it in there and
Got it.
Well, it allows you to basically specify that these people use bikes. Maybe some of the time when they use cars or they walk.
Exactly.
Or you can do
And dynamically, you could have it depend on an intervention. Before, more people were using their cars, and now more are using active transport, et cetera.
And also logic like if it's within a certain distance, you'll take a bike as well as you take a bike.
Exactly. Yeah. Yeah. So that's good. Okay. So, ladies and this is good. So, ladies and gentlemen, I'd like to refine this a little bit further, bearing in mind that lunch lies before us. And I'm not talking about screaming yellow zonkers at the convenience store. You will notice that people are moving back and forth. You should see this on your own. But you notice this person is moving. And if we looked at a more detailed route here, or detailed map, what we would see is that they are moving along particular thoroughfares. So this person is moving on Circle Drive and then down to, what is that, Highway 5? Down here, okay, this person has moved over to Sutherland. And they're traveling along the actual streets here. And that is a feature that comes out of using the GIS. It's conscious as to how you get there. Now, in a city like Saskatoon, this is a non-trivial issue because there's this thing called the river, which separates it. And the river only has certain bridges associated with it. And so while two people, a person might be proximate to the store that they want to go to as the crow flies, they may actually have to go quite a distance up to some bridges and down, and that may lead them to exhibit adverse health behaviors where they opt instead to visit the store next door called the Aussie's Market, which sells battered calves and floaters, where they are exposed to high levels of saturated fat, and over time they develop adverse results. Okay, ladies and gentlemen, so a bit of routing. Let's go tweak a few features of the model before we break for lunch. Feature one, and I credit Aiden for Aiden and Tina perhaps for sort of going and sleuthing this. Ladies and gentlemen, I'd like you to go to Maine. And you may remember me mumbling about a situation where the API was complaining bitterly to me. It engaged in what's called exception behavior and said, I can't perform the selected service when I asked it to locate things at random locations within the map. So, ladies and gentlemen, I'd like you to go to Maine, and I'd like you to go to Homes. And you may remember in Homes, we have this somewhat painful sort of selection of homes by location. We kind of went back and forth futzing. Do you remember that? And we said, it's not quite, doesn't look quite right. And we futzed it. Okay, so this is what I want to do, and I've got to plan this in my head. Okay, so right. Okay. Okay. Right. Oh, how am I going to do that nicely? Okay. Okay. So basically, what we can do here is we can ask it to pick a location inside of the city of Saskatoon. And the way to do this, yes, it's a thing of beauty once you see through it. Okay, so we're going to go associate each person, ladies and gentlemen, with each home with a parameter. Okay? I do this, there may be other people who need to do this in the future. So I'm going to go to home, and I'm going to go to palette. Okay? And I'm going to add into home a parameter. And this parameter will be called location. And the type of this parameter, ladies and gentlemen, is going to be other. And it's going to be capital P-O-I-N-T. Just the P is capitalized. Okay? Point. Are we okay with that? Now, we don't have to do it this way. In some ways, I'm more tempted to say latitude and longitude, but let's just do it this way. Point. Are we okay? Okay. Next, I'd like you, once you have this, who needs TA help? Okay. Let's go to main, and let's go to the homes. Now, by virtue of having that parameter, we need a location here. Do you see that? See that? Okay, watch this. We're going to say this dot Saskatoon. Ladies and gentlemen, the significance of this, if not the gravity, should not be lost on you. Each of you now has your personal Saskatoon. Okay? And if you had come earlier, you could have gotten many kilograms of them we picked from our bushes in the back. But anyway, we also call Saskatoon berries here Saskatoons. Okay, we got many dozens of kilograms this year from our backyard. Okay, this dot Saskatoon dot random point inside, and we call it. Okay, oops, we don't need that. We want this one. Notice that sometimes there's several versions of something. And here we're going to choose this one, which doesn't require any information to do its job. AnyLogic sometimes will find several, and by kind of navigating up and down using the arrow keys, you can select the one in which you're interested. And here we could say, we'll just say we want the one that doesn't require any information. Okay, by virtue of having done this, we're lending a location to this person, and we're assigning that parameter is going to have a location associated with it. Okay, who needs help? Is there a question? Okay, ladies and gentlemen, so that's our location. And now for the latitude and longitude, we're going to do location dot get latitude. Oh my gosh. Mumble. Okay. Location. Okay, we could just say at the animation. Oh, sorry. Mumble. Okay, I've got to do some fancy footwork quick on this. Yes. What's that? Okay. Location dot. What I want to do is I want to. Oh, sorry. Self dot location. Self dot location. Okay. Okay, no, it's proposing giant tiger to me. Okay, no, I don't want giant tiger. I want self.location.get latitude and self.location.get longitude. There we go. Okay. There we go. Thing of beauty. So what did we do? We associated each home with a location, and then we, for the population of homes, we drew that location from a random point inside the city of Saskatoon. Inside that geofence around it, inside that polygon, that irregular polygon. And now, by virtue of having this location, we can ask here for its latitude and here for its longitude. Now, you may wonder, those of you in the audience may have wondered, well, why didn't I just do this? Why, don't do this. Don't do this. Why don't I just do that? Those who were in the Java tutorial may have the answer yesterday. Why can't I just do that? Why?
Get a random, it'll pick a different.
It'll be a different random point every time. And I don't want that. I want the same random, I want the latitude longitude of a single random point. So I have to kind of get both and then parcel them out to the latitude and longitude here. Okay? So that's why I had to go associate this parameter with the person, and figuring out that on the fly is one of the fun things. Yeah, Chris? Do you,
I just need
TA help? So TA? Yeah, thanks. Okay, ladies and gentlemen. Okay, so we should be able to run this, and we should see a different picture now. Do we not? Do you see a different picture? So now we should see a situation where what? How should it be different visually?
Houses are inside.
The houses are all inside Saskatoon. They're even in these little irregular nooks and crannies. In fact, 2 of them are in the airport, I think. But okay, ladies and gentlemen, that was one improvement. Does anyone want me to upload that model? Would that be useful? Okay, so I'll save that as version 3, and I'll say, you know, elements, so houses, homes inside region only. Okay, boom. That will be one thing. And I'll go upload it here. Okay, and give me just a second. Boom. And here we go. File upload, and okay, it's there. So if you want to get that, I'll pause for a minute. Okay, next we're going to be doing something different, but I'll wait till people can download that. Okay. Great. No, that's not good. Yeah. Thing of beauty. Okay, ladies and gentlemen. Lunch beckons. And it beckons me as much as you. But we're going to do something that's going to take just 5 minutes, and it's going to have a big impact on the significance of this model. Are people ready to go forward? Okay, ladies and gentlemen, thus far, we made a choice. Okay. Thus far, we made a choice which had computational disadvantages as well as being somewhat strong assumption. When we had people go to supermarkets, when we had people go to supermarkets, we chose the supermarket to which they were headed with uniform, a discrete random distribution from amongst a set of possibilities. Okay, so we chose each supermarket with equal likelihood. Similarly, for convenience stores, we did the same. Now, this was fairly unrealistic in the sense that if there's many supermarkets nearby, it seems questionable whether one would go to another to just without preference sort of circulate to all supermarkets in the city. But not only that, in terms of routing the individuals, it led to a lot of extra routing needs because you were routing a given individual on a different day to extremely different areas. And it was, every time I was looking up, okay, how do I get from this particular house to that supermarket, now to this other one, now to this other one, now to this other one. It would be much more both realistic and computationally tractable, or require less communication and with the routing server if we had people tend to go to locations near them. So if there's a supermarket across the street, they're going to go predominantly to that one rather than to one way across town. And we're going to put in a simple approximation here so we can get to lunch quickly, although more sophisticated ones are readily possible with distributions. We're going to have them, instead of going to a randomly chosen one chosen with equal probability, we're going to have them instead go to the nearest one. Okay? So here, instead of saying get random from, we're going to say get nearest agent. Okay? Now, you'll notice that there's another option here as well. Get nearest agent by route. Okay? And I've used get nearest agent as well as get nearest agent by route in these sort of models. To be explicit here, we're going to use get nearest agent by route. Tell me, Scott, get nearest agent, is that strictly as the crow flies distance?
I believe so, yes.
Yeah, okay. That was my best guess, but I hadn't gone and validated that.
That would be my best guess as well. I can't tell you for sure, but
Yeah.
I know they added get nearest agent by route when they
Right.
improved the GIS capabilities in 7.1. So
Yeah. So get nearest agent by route will figure out the nearest of these convenience stores to you and allow you to reach it. Now we're abstracting over the issues that, maybe the Aussie convenience store that has the battered calves and the floaters and the broad selection of pies, that may be your, the hankering may be specific to that. But we're just going to say you go to the nearest convenience store, and similarly for the nearest supermarket, you're going to go to the nearest supermarket. Now, this reflects the fact that I'm not going to, in the other version of the model, the more fulsome version of the model, we actually are balancing the distance to a location with your preferences and with your other preferences for type of food. And we're actually computing the distance to these locations explicitly. And that's readily done in AnyLogic. Just as we could say, hey, get the nearest one by the route, we can also ask the distance to a particular one. Okay? And that's readily done. I think I don't remember. Yeah, get distance, and you can get distance in GIS, for example, and to certain latitudes and longitudes, for example, and you can get the distance as routed as well. So. But in this case, we're just going to do it, we're just going to be asking, get me the nearest one of the supermarket collection or the convenience store collection. I'm going to go to that. So now we'll have a lot less global travel between people, but also we're going to have people repeatedly going to the same resources. They're going to go to their favorite supermarket, or they're going to by distance, or their favorite convenience store. Okay? Net results of that, one of the results at a practical level is that even though we're hitting the server at the same time, the model will run faster because we're having so many repeat routes. Now you'll notice it's communicating with the server here, and the bottleneck in this case, sometimes we run this in situations where the network locally is a bit slow and the bottleneck may be in the local networks, and that often the bottleneck, and here certainly the bottleneck is going to be in the server, in contact with the server. You can see the imagery hasn't even loaded. We have this network activity, and it's sort of waiting for information. But because of the large number of routes, it's going to speed up. What's going to happen when you run these models is that by default they're going to cache their the results of their lookup. So it's going to grow a larger and larger sort of larder of routes that it knows about. And here, with a small population, that's quickly going to get to the point where it can route again and again and again in a fairly fast fashion. Question? Yeah.
I was curious, what's the persistence of the cache? Is it per run of the model?
No, it's actually persisted. It's a good question. It's actually persisted in the folder. So as long as, even if you keep on, even, it's not just the run, it's not just the model version. You can keep on modifying the model version, and it's actually going to keep on using that cache. I don't know if there are cases where it flushes it periodically. Scott might be able to comment on that. I've never encountered that, but if I were to go to my sort of set of example models, and we were to look at some here, I didn't upload the caches. I could have to sped things up, but like here we're going to have some food environment, GIS and food environment. You'll notice there's this cache, and the cache gets updated on an ongoing basis, but it's going to keep it in a subfolder of the modeling folder, and that's going to allow it to kind of reuse it on an ongoing basis if you're working in the same geographic area. Yeah.
A practical but maybe annoying question is that in the computing environment we have to operate in, we may have to move to a system where the box is disconnected from the world.
Right.
What is the implication for this map?
That's a good question. So do not despair. If there's a couple options available. Option is that if you go to the map over here, and you notice that you can set, for example, the routing server. You can choose accordingly, and you can you have some selection here. There used to be an option here. Sorry?
It's under advanced.
It's under advanced, okay, down below, where you could use your own infrastructure. Projection type is that. Yeah, custom route provider. And so this would allow you to use a sort of local resource. It might be a server within your particular facility, to which it would go for routes. Another option, if you can sometimes run your model outside of the facility, it will come with a big cache that it could use on an ongoing basis, even when you're disconnected.
That gives me something to go on.
Those are two options. We have also used this functionality in sort of lockdown situations at clients that have asked us to come give custom boot camps for them and large agencies where they're very strict network policies and where there's no way we can connect our machines or what have you. And we've set up something that probably will be counterindicated in your case, but they were perfectly happy with it for the sake of our use, which was we brought along a portable hotspot and we just set it up to use that.
We can't.
Yeah.
Those things are illegal.
Yeah. So you'll notice it's using the cache now. After going really slow for a while, now it's going really quickly. And one of the big reasons is they're going to the same destinations, right? And I'll slow it down a little bit so you can see this, see the move. Yes, Scott.
I'm just gonna say a couple things. One, I would suggest just basically if you have an issue with not being able to connect, I would use the latter option. And I mean, setting up a local tile and route provider is okay. It can take some work. Whereas if you just create a model that has nothing but the map you want to use, nothing about the logic. The maps are easy to get, and then you just have all the routes basically done. You just force it to just download all the routes. And use that cache for that would be how I would approach it. The other thing is that using get nearest agent by route will create a log jam at the beginning of the model, as you saw, for the simple reason that it has to calculate every route between every agent and every store to actually know which one's the nearest. Okay, as such, that's why you could stop this and run this and it'll be perfectly fast, but that's because it has to do every single route. Okay, and so it actually is a little bit more work up front instead of just saying get me a random one. Then,
But as such, it is doing the heavy lifting, which could then allow it to be disconnected.
correct. Yes. Yeah. No.
So having done that, it's got all this information. But mind you, it is in get nearest agent from route. It's doing so for the locations of these agents as they are there. If every time we started those agents at a different location, it would be searching for additional routes again.
You have that issue every time you start the model.
Yeah. So there's some considerations here. Also, I imagine if I switch map provider here, probably it would have to flush its cache. In other words, it wouldn't be able to reuse things exactly. I may be wrong on that. It's possible it's doing based on geographic, but if I changed routing server to be a different one, my guess is it might end up being forcing it to sort of recompute. Okay. In any case, that's a little bit about this. You'll notice that between your version of AnyLogic and mine, there are probably some differences that are visible. And I'm using 7.3.4, you're using 7.3.5. The GIS functions on a comparative level, they're evolving. They're an area of AnyLogic that is evolving faster than many other areas of AnyLogic right now. They went through a big spurt in 7 and went through a couple iterations, and now they're still churning a little bit, like in eliminating the default one is MapQuest, etc. There's some change going on there, so just be aware that 2 versions from now there may be some additional components in place here. But I have to say it's much better functionality than it was a few years ago. It's just incomparably better, and it's a pretty practical solution for a lot of needs that are pretty helpful. So where would this model go? Just so you're aware, if you were to look up this model, so this model is part of what I've given you, and we take this model and we incorporate into it what the skeleton of it is. Many elements of the skeleton are here, but then we incorporate into it a set of additional features, and I'll just go open it up here, it is going to have in it also a representation of parks. We have versions of this model where you interactively add supermarkets by clicking on places in which, if you're interested in modifying the built environment and the implications on obesity levels, that can be an interesting thing. So you have not only static resources as they exist now, but you can place new resources. And the important thing there is not clicking and so on. I mean, that can be useful for exploration, and it's kind of nice, but really it's the ability to just recognize when you have fixed resources read from GIS databases, you can mix them with new resources that you have elected to put down at locations of your choosing. So you're not rigidly set to only use those from a GIS database. You can mix them around. So if you want to, examine a situation, if we had more supermarkets in the inner city or something like that, you could add them. Another feature that we've explored, and again, this model is available for frobbing and for inspection. Another feature is, in addition, you'll recognize this is the state chart we created. But beyond that, we had, this was chosen with probability of shopping wisely, and this was chosen based on distances and preferences. Okay, it considers both an individual's preferences and distances to figure out which direction they go here, whether they go to the convenience store or supermarket. Also, we had a larder of the number of meals that they have remaining in their home. And when they go to a supermarket, they tend to buy more meals than to a convenience store. that's significant because they don't have to visit as often. If you could provide, transportation options to ease the trip to the grocery store, and maybe one they don't have to make once a day like they do for smaller purchases at convenience stores. Now, we further had within it a representation. This is notable in terms of client communication, a representation of the decision-making process about what meals that they eat. And, it describes sort of under what conditions they eat a supermarket meal or eat a convenience store meal, if they have both in their larder, etc. And that is used. This eat meal is a function that's illustrated visually as to sort of how I choose things. And incidentally, Kate, this is what I was saying could be used for something like the process someone might decide in terms of when they encounter breastfeeding difficulties, how they choose, do they go to a clinician or go to a lactation consultant. You'll notice that this little thing here is just a function. We just call it, and behind this is actually little snippets of code. So when they eat a supermarket meal, we lower the number of supermarket meals remaining, and they get energy intake suitable for the supermarket meal. On the other hand, when they need to go shopping, we will send a message to this state chart over here saying go shopping. In contrast to the rate transition in our current one, here we have a rate transition. Here it's triggered by a message when they're out of food, basically, or when they decide to go shopping. Beyond that, we had a very simple representation of weight dynamics where we had energy in being determined by the meals that they ate, and energy ate being determined on the one hand by sort of basal energy expenditure according to their weight. The higher their weight is, the more basal energy expenditure there is, but also with energy expenditure via physical activity that's affected by the nearest park, and that's that ends up influencing sort of the amount of energy that they're modeled as expending via physical activity. And both of those serve to lower the weight. Now, Amin here, I don't know if Amin is in the room right now, but Amin has been working on a very articulated model from the NIH, which can be incorporated into, and in fact, he's incorporated in AnyLogic, where it can be placed in agents. Instead of having this very simple model of weight dynamics, you could have a physiologically grounded and calibrated model of weight dynamics as measured in empirical studies. Okay, so that's where this model could go in the course of the afternoon. If we went to the afternoon, we could build those things. Yeah.
Why do some of the variables have hashes?
Yeah, that's a good question. The hashes were things that were alluded to something that Peter referred to yesterday in the Java tutorials. We can actually designate, and there's a bit of a subtle difference here, parameters and code assumptions and communicate assumptions from point of creation to where they're used. And beyond that, we can have what are sort of assumptions that we don't see a need to parameterize. They're just sort of constants we use, and we don't want to create them as a parameter. We treat them as what's called it's a constant variable. That sounds like a contradiction, a constant variable. But the point is, it's a number which we use, and we don't deign to call it a parameter. It's just something we use without rendering it to yet another parameter. And so the hash indicates that it's a constant. It turns out it's also, which is terribly confusing, and computer scientists should be severely chastised for this. There's this term static in computer science, which you would think is contraposed with dynamic, but what it means is there's only one value of it for all people. And this is a way of dealing with this awkward thing that sometimes there's things, conceptually it belongs in person, but if we put it in person, each person can have a different value of it, and we don't necessarily want to specify that every time we add a person to the population. This is a way of sort of associating a number, a constant value, with a person. It doesn't have to be specified for every person, and we can then use it here. So here we just use it, and it's a constant variable. And when I say that, I shudder almost because I think it's a horrible construct, but it's a constant. It's a constant variable, and then we end up using it just as a variable here. So that's what that hash means, okay? And it's a subtle thing, and I haven't come down firmly on one side or the other. So my students in different models, sometimes they'll use these for certain things. Sometimes for the same conceptual role, they'll use a parameter, and maybe for the sake of communicating with clients, it's better to use parameters. Anyway, that's where this model could go with the afternoon. And there's videos of me building this up with clients, with boot camp participants. But I think we've seen a lot of the core aspects of it here in our little model, particularly the things that I wanted to communicate with you, which involve movement in continuous space using things like move to and move to by route. The fact that someone is set in motion according to that, and then they, as we say, asynchronously, when they get to their destination, they wake up. I'll be with you in just a second. You know, it wakes them up and says you've arrived at your destination. Another thing that it brings out is the fact that movement times, how long it takes from someone to go to A to B, is endogenized. And what that means is we don't have to pre-specify someone spends this amount of time on the road. We don't have to calculate it ourselves. It emerges from the distance, their mode of transportation, how fast they're going. And in principle, one could further elaborate to take into account congestion or what have you. And that allows for sort of a fairly nice mechanism where travel time is something it figures out automatically, and it may bear on your choice of routes or what have you. So yeah.
I know we're bumping up against lunch, so could you, I don't want to hold this up, but could you just say a few seconds on what I think it was an action chart that was in there?
Yeah, the action chart.
How that, you insinuated it maps to a function?
Oh, I'm sorry, maps.
Does it map to a function?
Yeah, it's a function that it corresponds to. So an action chart here. By the way, I'm going to zoom in on this. Remember how you zoom in AnyLogic on a window? Anyone remember? I zoom in make it full screen. Anyone remember? Double click on it, right? Okay, so this action chart here is a admirably transparent and communicative way to characterize the logic that would normally be placed in a function that does some calculation. And in fact, there's a function over here which really needs to be unpacked into an action chart. So this is something you could show to a stakeholder. And what's going on here is that behind this, so basically it allows us to visually weave together a representation of different, technically the term is control flow constructs. I mean, they're basically representation of a little algorithm visually. And if you go over here to the palette, there's actually a palette devoted to action charts. And you'll notice that there's an entry point, which is this guy here. There's a decision point. But there's also code to sort of, straight line code to sort of undertake when you're doing the sequence of things, to do a sequence of things. There's while loops and do while loops and for loops and returns. In short, there's a bunch of mechanism that you can encode visually that you would normally put, didn't want that, that you would normally put in a function. So, where I could have this sort of code, instead I could use an action chart. Where it's particularly nice is where there's an articulated decision process involved and you want a stakeholder to understand it. But just to give you a sense of what's behind it, okay, so here's this thing here. With an action chart, very importantly, I have the opportunity to provide a sort of description for it with a label. And that label, is shown here, right? So I can have someone reading it see that label. Now, there's actually a condition behind here that's encoded in Java. This condition is testing, okay, do I have this many convenience store meals remaining? More than, do I have at least one of each convenience store meals remaining? In other words, do I have more than 0 of each of the 2 types of meals? But for the standpoint of the stakeholder, it could be characterized as, do we have both types of food to choose from? So I instead choose to have them see this. This is going on behind the scenes, secretly, but this is what they see. And similarly for this guy here, this little condition here. And then eat convenience store meals, there's this going on. By the way, those are the Java tutorial. You can see this minus minus where this is made one smaller. It decrements it, this increments it, makes it one bigger than its original value. But this code, they don't have to say it. I can just say eat a convenience store meal. So they'll see that. So this provides a kind of high-level, understandable view of what's going on, and it is a function. This returns, but it doesn't return a value. It just does something. It gets the person to consume a meal. You'll notice also that there can be actions in here that affect other parts of the model, like go shopping for food. This sends myself, can actually send the state chart over to the right, but it sends myself right now a message that says go shopping. And I deserve to be hit with a wet noodle because I just encoded it with a quote here, and I did this during a boot camp, and I inculcated horrible practices in them by sending quotes. But I think I didn't want to break the stride with introducing an option list at the time. So here, when that's sent, what happens is I receive it unconditionally. It's only one message, and that's why it doesn't really matter if it's a quote or not. It's only one type of message, and so I go here. Still should have dealt with an option list, just in case I want to add one later. There was, peer educator getting me to stop buying floaters or something like that. Or trying to wean me off of pies and get me to eat healthier food. Okay. Yes.
Under what circumstances would you use then on particular messages the fire transition rather than?
Oh, well, if your message, good question. If your message has several types, well, if your model has several types of messages, let me give an example. Maybe there's a model. So Tina over there, who's one of our new stars, she is the model of HIV infection. And one of the ways we're planning to extend that is with Hep C, hepatitis C, which is also spread via one of the predominant routes of HIV transmission here, which is intravenous drug use. And if you had exposure to Hep C and exposure to HIV, those might be different messages, right? So those might be encoded as different messages, and there you would have a HIV state chart, and getting infected with HIV would be gated by, would only depend on receiving an HIV exposure message, whereas the other one would be, the Hep C state chart would have a Hep C message. Alternatively, also in Tina's model is an admirable and growing representation of care-seeking behavior. And so there might be a message that's literally the result. We're doing the study with using our smartphone-based data collection system will be part of it, and using smartphones as interventions is one interest. So we might send a message to a patient saying, we noticed you missed your appointment for renewal of your medication. We'd like to book a new appointment with you. And that literally might be represented by a message in the model that someone receives, and they're more likely then to present for care in a short period of time. So that might be yet another message. And those would be cases where very different messages are required.
So those messages might be on an option list?
Yeah, so we'd encode exactly. So in the option list, we might have a HIV exposure message and a Hep C exposure and a appointment reminder message or something like that. Maybe there'd be another one that would be associated with actually going and encouraging to engage in better levels of self-care or what have you, in terms of taking their hearts, their highly active antiretrovirals. So
that's where it's communicating with the state chart transition, which has the message as the trigger for transition.
Right. Right, and it is possible in AnyLogic. We used to do more of it comparatively. It is possible in AnyLogic to route particular messages to particular state charts. So up here in Connect, you can say, well, for messages coming in via this might be forwarded differently. So, I might have a clinical support network for me as a HIV-infected patient, or as an at-risk patient, and that one I might route messages coming in via that to my care-seeking state chart, whereas I'd have a different network in place for my for my IDU use, my intravenous drug use. But even within the intravenous drug use, I might have a Hep C and a HIV message coming in, both via that particular connections. And there's this thing called on message received, which is kind of nifty because you can actually use it amongst other things to not only route messages to particular networks, but you can also use it to report very easily who sent me a message. Who is the sender of this message, what was it, and that can be useful for sort of trying to figure out why the model exhibits dysfunction when it comes to sort of agents interacting. So that's still there, and you'll notice it provides you with some information, like MSG is the received message, and sender is the message sender, so I could say, trace LN, I could say sender just received me, sender just sent me the message, and I could say MSG, and that will be printed out. One nice thing about option lists is they print out neatly, and you can see, okay, what's being sent around. So this is very good for debugging. Is that helpful comment?
It is, very much.
Okay, very good. Any other comments, questions? Chris, did I get to your question before?
Yeah. I just
Okay.
the only thing I would. So are they typically action charts are sent to by like an event? Is that a very common way to?
Action charts can be triggered anywhere you can call a function. So
just think of them like very.
So
just think of them like functions.
You think of them as I think of them as a function that's transparent, clearly documented for the stakeholder. As far as I'm concerned, so as a computer scientist, more than that, as a software engineer and software developer, functions are some of the main ways we build up systems, and you can use them to encapsulate functionality in rich ways. But when it comes to communicating with stakeholders, when there's a lot of logic trapped inside functions, it's not going to be visible to a stakeholder who's browsing the model. And much of what I think about is what Kurt underwent, what he experienced, what he flourished in, the environment, with the Ministry of Health, of having people look over his shoulders, or UN over there, or others, where people literally look over your shoulders while you're doing things. And it's off-putting if you have all this logic in a function, this core logic, and you just got to wave your hands and say, well, this function kind of does this. And it's just much clearer, I think, if you use action charts. And I know UN has been investing in them as well for her modeling, I think partly for this reason. When you have lots of people look at the model, it's just so much more clear about what's going on. And it instills confidence and conviction that the model is capturing things. Whereas if you say, well, there's, just trust me, it's in there, don't pay attention to the man behind the curtain, it's a little bit disconcerting sometimes. So I think action charts are the cat's meow for many, many cases. And occasionally I lapse in my use of them for expediency's sake, but I think they're great things. Okay, is that helpful? But you call them. In short, you call them. Eat meal is called here, and I could call it from a state chart. I could call it from an event, like I do here. I could call it from another action chart. It's good stuff. You just call it like you call a function. Hope that helps. Okay. Any others? Okay, let's go eat something. Okay. Now, maybe the TAs can help me find the king. Winchell.
341.